Hi, we continue our discussions about the design of torsional reinforcement. There are longitudinal reinforcement as well as the link. These reinforcements are meant to take tensile stress developed within the member, which is subjected to the torsional force. The tensile stress, if it exceeds the concrete tensile strength, torsional crack will develop in a spiral way along the member. This reinforcement helps to control the torsional crack. In the design of the torsional reinforcement, a thin wall box section is assumed. Shear flow develops within the effective thickness of the box section, and the interactions between the reinforcement and the concrete forms an imaginary truss member. The longitudinal reinforcement as well as the link will take the tensile stress, whereas the concrete, particularly the diagonal strut, are meant to take the compressive force. Through the derivations in terms of the trigonometry, as well as substituting the forces due to the reinforcement, as well as due to the applied torque, formulas of longitudinal reinforcement, as well as the torsional link are obtained. The derivation process you may refer to our previous videos. It was mentioned that the torsional reinforcement is to be added to the full bending and the shear reinforcement required. What does it mean? Now, if you see the reinforcement here, the way it is arranged is very identical to the reinforcement that you use to design for the bending moment, as well as for the shear resistance. In fact, you can use the same arrangement for the torsional reinforcement, just that those required for the torsional resistance will have to be added to the reinforcement designed for the bending moment as well as shear resistance. To further clarify this, you may refer to this diagram. Typically, by the time you design for the torsional reinforcement, you have already done the design for the bending moment and the shear link. If you could recall, these are the equations for the bending moment resistance, and these are the equations for the shear link. In terms of the design principle here, based on the calculations, you have already determined the amount of reinforcement for the moment and shear. And then after that, you have designed for the torsional resistance. You also get a set of the areas of reinforcement. Now, if you wish to have the same set of reinforcement to cater for both moment shear and the torsional resistance, you will have to add them up and use the total reinforcement in your design. Same applies to the link. You have link for the shear resistance. You have also link for the torsional resistance. If you wish to use the same set of the link to cater both shear resistance and torsional resistance, you will need to first set the spacing between the link to be consistent. Make this spacing here consistent. And then the amount of the areas for the link shall be added. Now there is a catch here. Due to different models used to analyze the shear resistance and the torsional resistance, the area here for the shear link represents two legs of the link, whereas the area here for the torsional is reflecting one leg only. With that, you have to do some simple conversions to make it consistent until you work out the total area of the link and determine appropriate spacing for the link. Now the idea here is totaling the reinforcement for the moment shear and the torsional resistance is meant to cater for a situation where the moment and the torsional loads are at its maximum state. Same goes to the shear and the torsional links. Now, if you merge the two areas together without adding them up, it is as if you are assuming when the member is subjected to moment, it cannot take the torsion, and vice versa. Same goes to the shear and the torsional link. This establishes the design principle for the torsional reinforcement. You have to add them up with the existing reinforcement that are meant for the bending and the shear. Knowing that you need to add them up, after you have done designing the torsional reinforcement, it may lead to you a situation that either the size of the bar that are used for the link and the bending moment resistance are to be increased, or you can add more bars in order to provide resistance to the torsional on top of the bending and shear reinforcement. Since we talk about the reinforcement, let us talk about some principles in terms of the design of the reinforcement for the torsional resistance. First, the link used for the torsional resistance must be fully anchored and close link. This arrangement is slightly different from the one that typically we use for the shear link. Sometimes we see industrial people, when they do the shear link, they do it something like this. This kind of arrangement of the shear link is not applicable. In another word, if your member is designed to take the shear and the torsion together, this kind of shear link is recommended as it gives you a greater resistance due to a longer anchorage length, especially in resisting the twist due to the torsional force. Second, for torsional resistance, same like the moment resistance, you need at least one longitudinal bar at each corner. This is also slightly different from the moment resistant rebar, especially when you're dealing with the singly reinforced beam. You know that singly reinforced beam only require you to have the tension bar without requirement of the compression bar. However, you know that industrial practice we will need one bar at each corner in order to hold the link. So eventually you will get also at least one longitudinal bar at each corner. Now, if you are talking about torsional resistance, even though it is singly reinforced, you will still need one bar at each corner. This is compulsory. And then based on the principle just now, the amount of reinforcement bar meant for the torsional resistance, it shall be added on top of the amount provided for the bending moment resistance. You can either increase the size of the bar or you can add more bars. Something like this, or probably additional bars here. Now the spacing between the bars here needs to be not more than 350 mm. I believe this is something related to a mechanism to control the crack. Exceeding 350 mm, the reinforcement bar may be too far away from each other and the effectiveness to control the torsional crack will reduce. Therefore, as a rule of thumb, you measure the spacing between the longitudinal rebar is not more than 350. Now you might want to ask, is there any requirement in terms of the minimum spacing between the reinforcement? I believe it is no. Now in the case that you need more reinforcement here, and you have more reinforcement arranged in the more packed manner, this might give you another additional message. Probably you need to consider redesign the size of the member. When the member is too heavily reinforced for the sake of the torsional resistance, One of the reasons it will be due to relatively small effective area as comparison to the torsional force applied onto the member. If you increase the effective areas, the amount of reinforcement bar required for the torsional resistance can reduce significantly. This will give you a more economical solutions in terms of the design for the torsional resistance. Let's say now you still have some constraint that you cannot increase the size of the section. Under normal circumstances, the constraint can be limited by the height of the member, especially when you need to hide the member within the ceiling space. You can simply increase the width of the member, make it with a smaller aspect ratio. By doing so, you can increase the effective area for the torsional resistance. At the same time, you allow more reinforcement bar to be arranged along the top and the bottom of the member. Although there are no requirement in terms of the minimum spacing, normal practice here, we will still need to ensure the spacing between the reinforcement at least greater than the minimum bar spacing in order to ensure the concrete can flow through the reinforcement during casting for quality bond between the reinforcement and the concrete. Now, regarding the reinforcement bar to be placed along the height or along the width of the member, normally we will put at the inner peripheral of the link. We don't put it outside of the link. Putting the reinforcement outside of the link are meant for surface reinforcement, which is normally used when you have very thick cover, or to be more specific, when you have axis distance more than 70. So this will be the recommended arrangements for the reinforcement bar in resisting the torsional load. Let me further clarify these two diagrams. Let's say your initial design for the moment resistance, which is singly reinforced. These are the amount of reinforcement bar required. And then after you've done the calculations, you will need additional reinforcement bar to be added up to the existing bar. You cannot use the existing bar as the torsional resistance bar. Now, if you need more bar here, the spacing between the bar cannot be more than 350. Regarding the link must be closed and fully anchored. Don't use the typical shelling that we use in the design for the shelling. There is also requirement for the spacing between the link. The link here cannot be more than the peripheral of the equivalent box section divided by 8. In another word, if you would like to merge the shelling with the torsional link, you need to make sure this and this are fulfilled. Either one not fulfilled, even though you provide sufficient reinforcement for the torsional resistance, the resistance contributed by the link is questionable.